Welcome to Unstuck. Today, number of islands, a classic grid problem that teaches you depth first search and flood fill, the same trick behind the paint bucket tool. We'll build it one line at a time and run it live. Beginner friendly, no graph theory background needed. The problem, actually LeetCode 200. You're given a grid of ones and zeros. One is land, zero is water. An island is a group of ones connected up, down, left or right. Count the islands. In our grid there are 3. If grid problems zašto intimidates you, this is the one that makes them click I like helps. Let's understand the plan before the code. The idea, scan the grid was the cell by cell. The moment you hit a 1 you haven't seen, that's a brand new island, add 1 to the count. Then flood fill it, walk every connected piece of land and sink it, turning those ones into zeros, so we never count the same island twice. Scanning continues, but that whole island is now water. Here's the outer function. 2 loops, walk every row and column. This line is the trigger. If the cell is a 1, we found land that hasn't been sunk yet. So we add 1 to the island count and then call sync on this cell. Everything connected to it is part of the same island, and sync will erase all of it before the loop moves on. Now there's the sync function. Now this is depth first search. The first thing always is the base case. If we've walked off the edge of the grid, or the cell is water or already sunk, stop and return. Getting this guard right is what keeps the recursion from crashing. Check the boundaries before you touch the cell. If we're still here, the cell is land, sync it, let it to 0. This is the crucial line. By erasing the cell now, we mark it visited, so we never come back and never count it again. No separate visited set needed. Then we recurse in all 4 directions. So down, up, right, left. Each call repeats the same story. Off the grid or water, stop, land, sink and spread. The recursion naturally floods across the entire connected island until it's surrounded by water and edges. Run it. It prints the grid, then finds island 1 starting at row 0, column 0, island 2 at 2, 2, island 3 at 3, 3. Number of islands, 3. Each starts at line is a fresh one the scan found after the previous island was fully sunk. Trace island 1. The scan hits row 0, column 0, a 1 count becomes 1. Sync 0, 0, set it to water, then spread. It reaches 0, 1, 1, 0, 1, 1, sinking each. The whole top left 2 by 2 block becomes water in 1 flood. When the scan later reaches those cells, they're zeros, so nothing happens, no double count. Complexity. Every cell is visited once and then sunk, so it's order rows times columns, linear in the grid size. The extra space is the recursion depth, which in the worst case, one big snaking island can be the whole grid. For giant grids, you'd switch depth first recursion to an explicit stack or a breadth first queue to avoid overflowing. And so then this exact pattern unlocks a whole family, flood fill and the paint bucket tool, max area of an island where sync returns a size, surrounded regions, rotting oranges with a queue instead. Learn number of islands properly and a dozen grid problems become the same problem. Common mistakes: forgetting the boundary check so you index off the grid and rust panics, forgetting to sync which makes the recursion loop forever and recount, and counting diagonal neighbors. This problem is 4 directional only, so up, down, left, right, never diagonal. Recap, scan the grid. Each new one is a new island. Flood fill, set course full with depth. First search to sync the whole thing so you never recount. Always write the base case first, bounds on water. Then sync and spread in 4 directions. Linear in the grid size, that's number of islands. Quick one. If these help you, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.